Hello, ladies and gentlemen. This is the paper for chemical engineering in GATE 2021, the general ability part. Let us solve the questions. The first question: details of prices of two items P and Q are presented in the above table. The ratio of cost item P to cost of item P. The ratio of cost of item P to cost of item Q is 3:4. Okay, so here are the items P and Q. These are the cost given. This is misprinting. This won't be there. It's 5,400. The cost of Q has not been given. Right now, what has been said is that the costs are in the ratio of 3:4. Discount is calculated as the difference between the marked price and the selling price, which is absolutely normal. The profit percentage is calculated as the ratio of the difference between the selling price and the cost to the cost, which once again is very normal. They have asked you the discount on item Q as a percentage of the marked price is how much. Immediately the first reaction that will happen on this information is that I will try to find out the cost of Q. How do I find that? See, 5,400 is the cost of P, which is at a ratio of 3:4 with Q. So the cost of Q will become 5,400 divided by 3 into 4. So this becomes 1,800 into 4 is 72,000 rupees. So I immediately write that the cost here is 7,200 rupees. Now the profit percent is 25%. So I can easily find out the selling price of Q. The selling price of Q will be 7,200 multiplied by 25% profit. So 125 by 100, and that can be reduced to 5 by 4, and with 4 once again this becomes 1800. So the answer is 9,000 rupees. Now if it is 9,000 rupees and the marked price, selling price is 9,000 and the marked price is 10,000 rupees, then automatically the discount on Q will be 1,000 rupees. They have asked me to find the discount on item Q as a percentage of its marked price, which is 10,000. So basically it is 1,000 divided by 10,000 multiplied by 100, which gives us 10%. So the answer will be 10%. Right? Given below are two statements, 1 and 2, and two conclusions, 1 and 2 itself. So let us see the statements. Statement 1. All bacteria are microorganisms. So how can you express this in a Venn diagram? You see, all bacteria are microorganisms. There can be another way of expressing this also. You see, all bacteria are microorganisms. Statement 2 says all pathogens are microorganisms. So here it will be how? Now, these are microorganisms and these are pathogens. So naturally, this also will do. Now we need to combine them, and for the combination we will select the most effective combination which can be produced if we combine these two. Now if we combine these two, see what can result. One thing that can result is this is the microorganisms and this is pathogens and this is bacteria. This can very well be the result. The second case that can happen is that these are microorganisms, these are pathogens and these are bacteria. The third case that can result is these are microorganisms, these are pathogens, and these are bacteria. This can also happen. And the other case that can happen is that these are microorganisms, these are bacteria, and these are pathogens. So all these four cases will be valid if we combine these two, because nobody has told us the relation between pathogens and bacteria. So all these four can be possible. Now let us check. Conclusion 1. Some pathogens are bacteria. Well, some pathogens are bacteria, this is correct. Some pathogens are bacteria, this is correct. Some pathogens are bacteria where some is 100%, this is also correct. But some pathogens are bacteria, this is not correct. So any one condition incorrect, I can say that this conclusion itself is incorrect. Let us go to conclusion 2. All pathogens are not bacteria. See, all pathogens are not bacteria. Obviously, this is correct. All pathogens are not bacteria, right? Only some of them are bacteria. So this is also correct. All pathogens are definitely not bacteria. So this is also correct. But all pathogens are bacteria or not bacteria. This is absolutely incorrect because all pathogens are bacteria here. So if one is incorrect, then the whole conclusion becomes incorrect. So this is also incorrect. Hence I will say neither conclusion 1 nor 2 is correct. So that's the correct answer. Let's go to the next one. There are 5 bags, each containing identical sets of 10 distinct chocolates. One chocolate is picked from each bag. Well, the question is apparently missing. Let me tell you the question that was actually there. It was find the probability that at least 2 of the chocolates selected are identical. Find the probability that at least 2 of the chocolates selected were identical. So this was the question given in GATE. So let us see how do we move about it. See, there are 5 bags and let us suppose the 10 distinct chocolates is say A to J, A, B, C, D like this till J. Okay, so and this A to J, these chocolates are present in bag 1, in bag 2, in bag 3 and so on and so forth in all the bags. Now I am picking up one chocolate from each bag. So obviously as per the rule of probability and at least 2, the probability of this whole thing, at least 2 are a dot dot dot. I'm not writing the whole thing, the question is apparent, the probability of that. Obviously any probability is equal to the favorable outcomes divided by the total outcomes. Now what are the total outcomes? What are the total outcomes? Yes, let us first discuss that. See, if I select one chocolate from a bag, in how many ways can I do it from bag 1? I can do it in 10 C1 ways. In bag 2, how many ways can I do it? Once again, 10 C1 ways. Bag 3 also the same. Bag 4 the same also. So can't I say that the total outcome would be equal to 10C1 into 10C1 into 10C1 5 times. That is 10C1 to the power 5, which is nothing but 10 to the power 5. That is the total possible outcome. Now let us consider the favorable outcome. What is the favorable outcome? That at least 2 of the chocolates were identical. This is the favorable outcome. Now, what does at least 2 mean? At least 2, what does it mean? At least 2 includes 2 chocolates, includes 3 chocolates, includes 4 chocolates, includes 5 chocolates. I hope you can understand. It can't be more than 5 because there were 5 bags, and from each bag you are selecting one. So at least 2 will include all of these. The only thing that it doesn't include, these or it includes. The only thing it doesn't include is none are identical. This it doesn't include within at least 2 are identical. So we think that here we have to find out 4 different cases, pretty lengthy. So rather than that, let us find the probability that none are identical. None are identical. Let us find the probability of that. How do we do that? Very simple. The favorable outcome here would be equal to, see, I am picking up and none of them is identical. So from the first bag, I select any one out of the 10. In the second bag, I take care to see that the one that I had already selected doesn't fall in my option. I select one from the other 9 present. So that would be 9C1. From the third bag, I do not select any one of these 2 already selected. I select my chocolate from the other 8 present. So that would be 8C1. From the fourth bag, 7C1. And from the fifth bag, it would be 6C1. And obviously, since I'm doing them all together, so rule of multiplication. So this would be the favorable outcome for none are identical, and the result is 10 into 9 into 8 into 7 into 6. So see, 7 into 6, that's 42. 42 into 8 would be 336. Yes, 336. 336 into 9 would be 3024. Yes, 3024. And 3024 into 10 would be 30240. So this is the total favorable outcome. So the probability of none are identical is 30240 divided by the total outcome is the same for everybody, which is 10 to the power 5. Now, if none are identical, probability is this, and in at least 2, all the others fall excepting this, and I require to find the probability of at least 2. Won't I say that this probability will be equal to 1 minus 30240 divided by 10 to the power 5, which is 30240, so that is 0, 6, 7, 9 and a 6, 69760 divided by 10 to the power 5. So 1 place, 2 place, 3 place, 4 place, 5 place, decimal will shift, that is 0.6976. This is my probability. I will take this. I presume this is a misprinting, and even if it is not, even if it is 6979, the nearest that it comes to 6976 is this one only. The others are very far apart. So automatically I will take this only. And that's our correct answer. I presume that is understood. Let's move on to the next. Consider the following sentences. Everybody in the class is prepared for the exam. Babu invited Danish to his home because he enjoys playing chess. Which of the following is the correct observation about the 2 sentences? And from the options I find that we have to comment about the grammatical correctness of the first. The first one is about grammatical correctness. And for the second, whether it is ambiguous or not so. Okay. Now, see, everybody in the class is prepared for the exam is absolutely grammatically correct. Let us look at the second one. Babu invited Tanish to his home. Very nice. Because he enjoys playing chess. There is one point where there is an ambiguity. He refers to whom? Because he can be Babu himself, or can be Danish also. So any one of them could have substituted for he. So I will say that this sentence does have an ambiguity. It is not unambiguous. So the correct option would be sentence number 1 is grammatically correct and sentence number 2 is ambiguous, which is present in C. So C is our correct option. The ratio of boys to girls in a class is 7. It should be 7 is to 3. 7 is to 3. Among the options below, an acceptable value for the total number of students in the class is which one? Now you see, if boys is to girls is 7 is to 3, we all know that boys can be said to be 7 by 10 of the total number of boys and girls, and girls can be said to be 3 by 10 of the total number of boys and girls. Now we must understand one thing, that boys and girls can never come in fractions. It is bound to be integral. I mean, you can never get half a boy, right? Or you can't get 1/4 of a girl, can you? So naturally, the total must be some value, which must be a multiple of 10 in order to give an integral value. Now, let us look at the options. See, out of all the options, only 50 is a multiple of 10. So I will say that the acceptable value for the total students in the class is 50. We have two rectangular sheets of paper M and N of dimension 6 centimeter into 1 centimeter each. Sheet M is rolled to form an open cylinder by bringing the first, let us draw this. You see, we have 1 centimeter into 6 centimeter. This is, say, suppose sheet M, and sheet N is also the same. So that is also 6 and 1. Let us suppose this is sheet M. So sheet M is rolled to form an open cylinder. So from sheet M, what I endeavor to manufacture is sort of a cylindrical shape like this. By bringing these are the short edges. By bringing them together, say suppose here, it has gone here and the other has come up here like this. The cylinder is formed. Sheet N is cut into equal square patches and assembled to form the largest possible closed cube. Now I know that every cube has 6 faces and all the faces must be a square. That is the property of a cube. So I can say that I can divide this into 1, 2, 3, 4, 5 and 6 divisions. If I divide it into 6 equal divisions, then each of these lengths will be 1, right? Because it was totally 6. And this also will be 1, right? Obviously, this was already 1. So you can see I have achieved 6 squares. And hence, I can form the cube out of those 6 square things. So this is the cube. Now let us find out what they have asked. Assuming the ends of the cylinder are closed, the ratio of the volume of the cylinder to that of the cube. I assume that these ends are closed. In that case, what is the volume of the cylinder? The volume of cylinder is given by pi r square h. Now I have to find out what R is. I know what H is, that is 1, because this is only H1. Now I need where to find out R. Now you see, when it is made into a cylinder, the upper edge is something like this, of a circle form, where the circumference is 6. Now this has a radius which is the R mentioned here. So we know that the circumference is given by 2 pi r, and coincidentally it is 6 here. So what will be the value of r? See, r would be equal to 3 by pi. So right now we know that r is equal to 3 by pi. So basically what will be the volume? Now it would be pi into 3 by pi whole square. I mean 9 by pi square multiplied by 1. So pi and pi goes on. So this becomes 9 by pi. Now let us go into the square and find its volume. We know that this volume of a square is L length into length into length, because all the sides are equal and all the values are 1. So naturally I will say that the volume is 1 cube, that is 1 square centimeter. This is also square centimeter. So they have asked you the ratio of the volume of cylinder to that of the cube. So we will say that the ratio is 9 by pi divided by 1. That is equal to 9 by pi itself. And we will take this one, which is the correct option. Right? A polygon is convex if for every pair of points P and Q belonging to the polygon, the line segment lies completely inside or on the polygon. Which one of the following is not a convex polygon? Just by the definition of a convex polygon, we can say that our correct option will be this. How? See, let us select the points P and Q as these two. So then PQ will lie on the edge, right? The line segment lies on the polygon or inside the polygon. It lies on the polygon. Had P and Q been this and this, the line would have been in the polygon. So any side, any point you pick up, you'll see it will either lie on or in. So this is not this is indeed a convex polygon. This is a convex polygon. Here also it is the same thing. Whether you pick the points here and here, the line lies on the polygon. Whether you pick the points here and here, the line lies inside the polygon, and the same for all the other points also. So this is also a convex one. See, this is a triangle and it is the smallest possible polygon. So the points will always lie, the line with PQ will always lie on the polygon, wherever you place it. So this is also convex. But here, see, take this example. P and Q lies here. Then what will this line? This will pass through outside the polygon, right? Hence, it is not a convex polygon. Okay? See, doctor is to surgery as writer is to book. It's a very simple one. See, the option is also there. The rest of them simply do not fit in. Okay? So that will be the correct one. A circular sheet of paper is folded along the lines in the directions shown. The paper, after being punched in the final folded stage as shown and unfolded in the reverse order of folding, will finally look like what? See, when I unfold it, there will be a hole at the center because of this. Now this one is a slightly larger cut. So because of that, it will be a larger cut like this. But then this fold will come up to this also here when I unfold it. So that same cut will also be here also, slightly larger. So this is a smaller cut. So here there will be a smaller cut. But since I refold it back there when I unfold it, so this smaller cut will be here also. So you see the circular shape should look somewhat like this. And if you check the figures, this is the one which resembles this. So I will say number A is the correct option, right? Some people suggest anti-obesity measures, AOM, such as displaying calorie information in restaurant menus. Such measures sidestep addressing the core problems that cause obesity. That's poverty and uh, income inequality. So that's the passage. Of course, there shouldn't have been a comma here. There should have been a full stop for the correct grammatical effect. I think this is a printing error. Some people suggest anti-obesity measures such as displaying calorie information in restaurant menus. Such measures sidestep addressing the core problem that cause obesity, that's poverty and income inequality. Which one of the following statements summarizes the passage? See, the first statement is AOM are addressing the core problems and are likely to succeed. Nothing can be farthest away from the truth because it has been clearly said that these measures sidestep addressing the core problem. Sidestepping means avoiding addressing the core problem. So naturally this is not our statement. Okay. Second one, if obesity reduces, poverty will reduce. Since obesity causes poverty. But it has been clearly written that poverty causes obesity. See, such measures sidestep addressing the core problem. What is the core problem that causes obesity? That is poverty. So poverty causes obesity. They have said here entirely the opposite thing. So that is wrong. Number C, the proposed AOM addresses the core problems that cause obesity. And naturally, like the option A, it's obviously the opposite. They do not address the core problems. So this is wrong. Let us look at the fourth one. AOM are addressing the problem superficially. Superficially means on the surface, not going to the depth of it, which is absolutely what they have been saying. See, they do not address the core problem. Core is available in the depth. Okay, so they go superficially. So I will say that our correct option is this one. And that's the end of it. Thank you.